This conference will now be recorded.
Very good evening, students. Today, as we have already learned the concept of ampli amplifier and switching action of transistor in CE configuration, today we'll take up few numerical examples. Today we'll take up few numerical examples and try to solve those problems depending on our knowledge. So let us start. So first of all, let me tell you these questions are all taken from neet paper, neet previous year's neet paper. Suppose this problem which I'm showing you here in the screen now, it is taken from neet 2012 paper. Hi Deepa. So it is a paper from neet 2012. So we are solving, Deepa, we are solving few numerical problems on transistor, on the topic transistor. Okay. So just now we have started. Let us solve the first problem. This problem is saying that the transfer characteristics. So what is transfer characteristics? When we plot output signal versus input signal, that is called transfer characteristics. For a base biased transistor in C configuration, if we remember, base bias C configuration is this one. Base bias CE. CE means common emitter. CE means common emitter. Common emitter configuration. Okay, this is the particular configuration. Okay, CE configuration where you can see the emitter is grounded and base is biased with a battery. So this is called base biased common emitter configuration. Okay, this is what if we plot output voltage, that means the voltage across this VCE. Okay, so this is V output and input is VBE, sorry, VBB. This is VBB. So if we plot output with respect to input, then this type of curve we will get, and we have already discussed that. Already we had discussed this curve. Do you remember? So see, first region, this will be cutoff region, then this will be active, and then this is the saturation region. Okay, now the question is for using transistor as a switch. If we want to use a transistor as switch, then it is used in region 3, whether in this saturation region. See, this region is saturation region. Saturation region. The first is actually cut off region, where transistor does not conduct. Cut off region, and this part having negative slope, this is called active region. Second region is called active region. We have already discussed the switching action of a transistor. In the, if you want to use a transistor in like as a switch, your biasing should be such that the transistor will not remain any time in the active region. It will be either in the cutoff region or in the saturation region. So then you will have this option. Option B will be the correct. If you want to use a transistor as switch, then your transistor has to be operated either in cutoff region 1 or saturation region, that is region 3. It should never be in the active region. This is the answer. So both in region 1 and region 3, region 3, why this P I don't know. This P should not be there. Okay. So this is the question and we have got the answer also. This is very simple problem. If we remember the switching action and this transfer characteristics, then it is easy to solve. Now let us go to the second question. So what is the second question saying? The transfer ratio beta of a transistor is 50. What is this beta? Beta is actually current gain. Current gain. It is stated as transfer ratio because it is the output by input. Okay, output current is IC and this is IB. So that's why it is called transfer ratio. So this is given. This is actually current gain. Okay, current gain. Transfer ratio actually meaning is the current gain. Okay, so beta is current gain, which is IC by IB. This is what is given as 50. Now let us read the rest of the problem. The input resistance of the transistor when used in common emitter is 1 kilo ohm. So input resistance also is given. Let us write Ri is 1 kilo ohm or 1 in 10 to the power 3 ohm. This is given. Now you have to find out the value of peak of the collector current. Okay, peak of the collector current of an AC input voltage. If the AC input voltage is fed to the circuit, how much? This much, 0.01 volt. So if you remember that, see here I have to find out IC. How do you find out IC? We know from this definition itself you can find out. If you know IB, then you multiply beta to find out IC. So this is the unknown parameter we have now, that IB has to be calculated. So how do you calculate IB? See the input voltage. See IB means actually base current or input current. Okay, you can say type of input current. Okay, so input voltage is given how much? 0.01 volt. This is the peak value of the input voltage. So you know base current, then what will be the base current? The input voltage divided by the input resistance, that will give you the current. So what is input voltage? That is 0.01 volt and resistance is 10 to the power 3 ohm, 1 kilo ohm, right? So this is the thing. Now you look, this is 10 to the power minus 2 and this is 10 to the power minus, so 10 to the power minus 5 volt, sorry 5 ampere. So this you can write as 0.1. Okay, let us write this. Let us keep this is as it is. Now we'll calculate IC. IC means beta into IB. Sorry, IB. So beta is 50. Okay, beta is 50, and this is 10 to the power minus 5 ampere. So this will be 50 micro, sorry, not 50, it will be, see, it is actually, it is becoming 5 into 10 to the power minus 4 ampere. So if you convert this into microampere, then it will be 500 microampere. Okay, so this is the answer. So what is the answer? Option D. So option D will be the answer. Deepa, are you getting my point? How I am solving the problem? It's a very simple problem. The first two problems are very simple problem. Okay. So here beta was given, beta transfer ratio. This sentence is actually bewildering. You might be thinking, what is this transfer ratio? You should not think that too much. You should remember that beta means current gain. So then I can write this current gain IC by IB is equal to beta. So if I know IB, then it is easy to find out what is IC, because you are asked to find out AC input, sorry, AC current in the collector AC current, and the peak value of the AC current. So peak value will be this 500 microampere. All right, so let us go to the next problem. So here also, the, see, this is for a transistor, IC by IE. Actually, this is common base configuration. This is for common base configuration. For common base configuration, CB, common gas, common base, common base, common base configuration. In case of common base configuration, the ratio IC by IE is the current gain, small signal current gain, current gain, and it is denoted by, alpha. So what is that? Alpha is equal to IC by IE, which is equal to 0.96. Okay, this is the thing is given. Now you have to find out the current gain in common emitter circuit. So common base circuit current gain is given, and that is defined as IC by IE. Now you have to find out what is common emitter current gain. What is common emitter current gain? Common emitter current gain just now we have already discussed. So that is beta is equal to IC by IB. This is actually common emitter current gain. Common emitter current gain is IC by beta is equal to IC by IB. So look here, you have been given alpha, you have to find out beta. So there will be a natural question, because C is common, whether this C, beta and alpha, they have some common relationship, that you have to first find out. Okay, let me clean everything and I'll tell you what are the relations between alpha and beta. So that is the first question that we should have, that whether, so alpha means IC by IE, which is given here as 0.96, and beta means IC by IB. This is beta. Okay, this is the current gain in common emitter configuration, and this is current gain in common base configuration. Anyway, so we have to recollect, or we have to understand whether there is any relationship between alpha and beta. Okay, whether you have some relationship with alpha and beta. Answer is yes, we have two relationship. See, we can write either beta is equal to alpha by 1 minus alpha, or we can write alpha is equal to beta by 1 plus beta. Alpha to by plus beta. So here alpha is given, beta will take, we'll just for the timing we'll forget this, we'll use the previous one because alpha is given. So from there we will be able to find out current gain for in common emitter circuit. So alpha is 0.96 divided by 1 minus 0.96. Okay, so let us solve it here. So this will give you 0.96, right? So 0.04. Okay, so you get here, this is 0.96, this is 0.04. Now if we will remove the point, this, so we'll make them whole number. This will be 4, this is 96, so it will be eventually for 24. 24 will be the answer for this question. So you know alpha is this IC by IE. You have to find out beta, that is IC by IB. So you should remember this the relationship between alpha and beta. So I'll write once again. If you write alpha, if beta is given, you want to write alpha, then beta, sorry, alpha is equal to beta by 1 plus beta. This is alpha. And when we are writing beta, then we have to write alpha divided by 1 minus alpha. Okay, so these are the formula. You should remember this. We'll go to the next one. So this is common emitter amplifier has a voltage gain. Common emitter amplifier has a voltage gain 50. And input impedance is given as 100 ohm and output impedance is given. So you have to find out what is the power gain. Okay, so you have to find out what is the power gain. So voltage gain is given. You have to find out power gain. I hope you remember how to find out power gain. Actually, there are two ways to do. If you know beta, in that way you can do, or if you know the current gain, already you know the current gain and you know the input and output resistances. So from there also you can find out what is power gain. Let me write what is power gain. So power gain is equal to voltage gain square by resistance gain. Resistance. Okay, let me write in symbol. Then I'll write the meaning of the symbol. AR. So where AV is voltage gain, and AR, these are called resistance gain. This is called resistance gain. But what is this resistance gain? How to find out resistance gain? Like say current gain, we can find out output current by input current, and voltage gain we can find out by taking the ratio of output voltage to the input voltage. Similarly, resistance gain AR will be written as output impedance, output impedance, just a minute, output impedance divided by input impedance. Input impedance. Okay, so what is output impedance and what is input impedance? So we know input impedance is 100 and output impedance is 200. So 200 ohm by 100 ohm gets cancelled. So you will get only 2. So what is current gain? Sorry, resistance gain. Resistance gain is 2. Now let us put it here. Now let me clean this. So voltage gain divided by voltage gain square. Voltage gain square means 50 whole square. And current gain we have already found out to be 2. So this is power gain, so there will be no unit anyway. Gain will be a number, multiplicative factor, in fact. So this will be this much. Okay, so the option C will be your correct answer here. Deepa, are you getting my points? You should just here actually nothing to understand too much. You should remember what is power gain, how to write power gain. That is AV by AR. What is AR? AR is impedance gain or resistance gain. That is output resistance to the input resistance. Okay, so we'll move on to the next problem. So this is another problem which we have to solve. Look, this problem is related to the amplifier, CE amplifier, right? You can see that it is written already. The input signal given to a CE amplifier is given. So what is that? Input of CE amplifier having a voltage gain 150. It has voltage gain 150. Now input voltage is given. Input voltage is given. So what are the things given? I'll write once. See, you have been given voltage gain. voltage gain, that is denoted by AV, that is how much? 150. So what is voltage gain? That is output, V output divided by V input. So this is equal to 150. So can you find out what is V output? If your input is this much, look, V output will be V output will be V input into 150. So this is the answer. So what is input? Input is given here. You look. So this will give you the amplitude of the output voltage. So this will give you the amplitude of the output voltage. V output, amplitude of output voltage will be how much? This will be, see, amplitude here 2. So 2 into 150. So 300 will be amplitude. Okay, so we have got this amplitude. We know it will vary, output also vary as cosine function, but you have to find out whether there is any change in the argument of cosine. Answer is yes, there is a change in the phase. In case of amplifier, always the amplified signal will be out of phase by pi. Pi out of phase. So output will be always pi output. Output will be always pi phase away. Okay, or pi phase ahead. There is phase difference in CE amplifier pi between input and output voltage. Okay, so we have got the, see, if I write VO, this I can write, then amplitude I have got 300, then cos of, in a omega t, frequency is not going to change. This let it be the same. What is this? This is a phase factor, and phase will be 180-degree ahead. Okay, then if we simplify it, what is the answer we should get? We should get 300 cos of 15. So frequency doesn't change, so this term with multiply with time, multiplied with time, will remain as it is. Only here will be the change, that is the phase change. So it is pi by 3 plus pi, so it will be 4 pi by 3, and hence the first option will be the correct answer for this question. Okay, Deepa, do you understand this problem? Voltage gain is given, so voltage output by input. Okay, so gain into input will give you the output, but that would give you the amplitude only. Then inside the argument of the cos, you have to find out whether that term will be identical or something given out of this 4. So how to analyze that? This term is actually, see, this is omega into t. This is not going to change because input and output frequency will be the same. Only difference will be there in the phase. And amplifier output is always pi radian ahead, or there is a phase difference between input and output of an amplifier amplifier as 180 degree or pi. So that's why I have added the pi, and hence we get 300 cos of omega t, that is 15 into t plus 4 pi by 3. So this is like first option is the correct answer for this question. Okay, so this is how you have to solve problems from transistor. Another last problem I'll take up. So this problem, let me complete the problem here. This figure is given. This is actually from NEET 2018. So this is from NEET 2018. Look here, let me write the question. In the circuit shown in the figure, the input voltage, let me write the question. This is question 6. Okay. In the circuit shown, in the circuit shown, in the figure, in the figure, the input voltage Vi, the input voltage Vi is 20, right? As you see, 20 volt. VBE is given. What is VBE? VBE is given as 0, and also VCE is given 0. Okay. Then what you have to find out? You have to find out IB, IC, and IB, IC, and beta. Okay. So this is the question. So in the given figure, see the input is given. Input, see this input voltage Vi is 20 volt given. Input, see this is the resistance RB is given, and here this is also is connected with the battery 20 volt, and RC 4 kilo ohm is given. Now you have to find out the value of IB, IC, and beta. So first of all, what is IB, what is IC, what is IC, and what is beta? To solve this problem, what you have to do? To solve this kind of problem, you have to write down Kirchhoff's voltage law. Kirchhoff's voltage law in for the both junction, input junction and output junction. So what is the input junction? Let me complete the input loop. Let me write input loop. So this is suppose the battery VBE. So this will be like this. This is a complete circuit or complete loop in case of input, and the figure was given was in a very smart way. Okay, so this is 20. So now according to according to Kirchhoff's voltage law, what we can write is I'll write, see, this is V input, that is the power, total power, that will be equal to RB IB plus VBE. Here VBE is given as 0, therefore this actually is 0. So therefore IB will be is equal to VI by RB. Okay, so V input is what? 20, and RB, that is the resistance connected series with B, the base part. So that is given as 500 kilo ohm. That means this is 10 to the power minus 3 again. Look this, or let me write this as 10 to the power minus 10 to the power minus 5, and this is as 4. 4 into 10 to the power minus 5, that means 40 microampere. 40 microampere. Base current is generally in the microampere order, not a microammeter. Microampere order. So 40 microampere, and then what will be IC and beta? So here, if I would have had this beta, then I could write that IC is equal to beta into IB, but now I cannot do because I don't know even IC. So how to find out IC? Similar way, you complete the circuit. So this part you have, this is also 20 only, this is 20. This is 20, sorry, 1 minute. Let me write this as VCC, which is 20 volt now, is equal to ICRC into VCE, where VCE is given as 0. Then from here it is very easy to find out RC. RC means VCC, or input voltage in the collector circuit, divided by RC. So let me just do the simplification over here. Look here, actually sometime this mouse pointer is not visible in the screen, that's why I have to do this. So IC will be VCC, that is 20 divided by 20 divided by RC is 4 kilo ohm. So 5 milliampere. So it will be 5 milliampere. Okay, so we have got, let me tell you what we have got so far. We have got IB to be 5 microampere. IC is thought, sorry, we have calculated IC as 4 milliohm, sorry, milliampere. Then you have to find out what is beta. Beta is IC by IB. So what is IC? 5 into 10 to the power, sorry, 4 into 10 to the power 4 into 10 to the power minus 3 divided by 5 into 10 to the power minus 6. So it will be 4 by 5. This is 10 to the power minus, sorry, 10 to the power plus 3. And if you make it 0.8 into this, so you'll get 800. Okay, 800 will be the I think I have done some mistake somewhere. This will not be that much. It will be somewhere around 150. Okay, let me just do one thing. I don't know what I have. Oh, current is IB is actually IB is 4 microampere, and this is, let me just redo that. IB was 20 volt by 500 kilo ohm, right? 500 kilo ohm means this much. So this was 4, not 4, 40. Oh, sorry. It was actually 40 microampere. Okay, 40 microampere. As you see this, and IC will be again 20 divided by 4 kilo ohm. This is 10 to the minus 3. So it will be 5 milliampere. Now beta will be IC by IB. That means 5 into 10 to the power 3 divided by 4 into 10 to the power, sorry, 40 into 10 to the power minus 6. That means you have this into 10 to the power 3. This is the 1/8 into 10 to the power 3. That means this is 125. Okay, 1000 by 8 means 125. So you get IB. So see here what we have to do in summary. For both input loop and output loop, you have to write down the Kirchhoff's voltage law, and from there you can solve this problem. So IB is 40 microampere, then IC is 5 milliampere, and beta will be 125. Okay. So with this, I'll stop it here. Next day, we have little portion remaining, feedback amplifier and digital, that logic circuit. We'll try to learn logic circuit and feedback amplifier in the next class. Okay, so that will happen on Wednesday. So bye for today. Deepa, if you have any question, you can ask me in the next class. Today we'll stop it here because you have class again, right? It is going to be 5 o'clock. Okay, so thank you for your patience. You just go through once these problems and see whether you can understand. If you have any question, you can let me know in the next class. Okay, so bye for today.